Your production cluster is humming along. Suddenly, a spot instance vanishes, pods die mid-request, 500 errors spike, and Kubernetes has no idea what just happened. The node simply disappeared. The problem is not Kubernetes. The problem is that Amazon Web Services knew the node was about to die, but nobody told Kubernetes in time. That is exactly the gap AWS Node Termination Handler fills. In this masterclass, we cover what NTH is, the problem it solves, every disruption type, both operating modes, end-to-end event flows, the critical decision between self-managed nodes, managed node groups, and Karpenter, draining and pod disruption budgets, observability, production patterns, and a complete mental model. Let us begin. AWS Node Termination Handler, or NTH, is an open-source component maintained by Amazon Web Services. Its job is simple but critical. It detects when an elastic compute cloud worker node is about to become unavailable and tells Kubernetes to move workloads away safely before the node actually dies. Think of it like a fire alarm system in an office building. The building management, that is AWS, detects a gas leak. Instead of waiting for the ceiling to collapse, the alarm sounds and people evacuate in an orderly way. NTH is that alarm for your Kubernetes cluster. At a high level, NTH performs 4 actions. First, it detects a disruption signal from AWS. Second, it maps that signal to the correct Kubernetes node. Third, it cordons the node so no new pods land there. Fourth, it drains the node by evicting running pods so they can be rescheduled on healthy nodes. That sequence is the core of everything NTH does. Before NTH, many Amazon Elastic Kubernetes service environments had a dangerous blind spot. AWS knew a node was about to be interrupted. Kubernetes did not. The instance vanished, kubelet disappeared, pods died without a clean shutdown. Services kept routing traffic to dead endpoints, and stateful workloads suffered longer recovery. Imagine a restaurant where the health inspector knows the kitchen has a gas leak, but nobody tells the waiters. Customers keep getting seated, orders keep flowing, and then the kitchen shuts down mid-service. That is what happens without NTH. Kubernetes has built-in node health checks, eviction logic, and graceful shutdown features. But by default, it does not automatically know about cloud provider-specific signals like spot interruption warnings, rebalance recommendations, or auto-scaling group lifecycle events. NTH bridges that gap, translating AWS infrastructure events into Kubernetes node lifecycle actions. Understanding the threat model starts with knowing every way an EKS worker node can disappear. There are 6 types. First, spot interruption. AWS reclaims a spot instance and gives you roughly a 2-minute warning. That is tight. Second, scheduled maintenance. AWS may notify you about hardware retirement or planned maintenance affecting an instance. Third, auto-scaling group scale-in. The ASG reduces desired capacity and terminates an instance. Fourth, availability zone rebalancing. The ASG moves instances across zones for better distribution. Fifth, instance state change. Someone terminates the instance via the EC2 API or console. Sixth, rebalance recommendation. AWS warns that a spot instance is at elevated risk of interruption, even before the 2-minute termination notice. Each of these signals arrives differently and provides a different amount of lead time. NTH needs to handle all of them. NTH supports 2 distinct operating modes, and choosing the right one matters. Mode 1 is the Instance Metadata Service Processor, or IMDS mode. Think of this like a smoke detector wired directly inside each room. Each node has its own NTH pod watching the local metadata service for disruption signals. It is deployed as a daemon set, one pod per node. Simple and self-contained. Mode 2 is queue processor mode. Think of this like a centralized security monitoring station watching camera feeds from every room. NTH runs as a single deployment that pulls an Amazon Simple Queue service queue. That queue receives events from Amazon EventBridge and auto-scaling group lifecycle hooks. Here is the key difference. IMDS mode is simpler but limited. Queue mode is more powerful, supports lifecycle heartbeats, and handles a wider range of events. We will deep dive into each one next. Let us go deeper into instance metadata service mode. Each NTH pod runs on a worker node and pulls the local IMDS endpoint. When AWS publishes a spot interruption notice or scheduled event into the instance metadata, the local NTH pod detects it immediately. IMDS mode can detect spot interruption notices, scheduled maintenance events, rebalance recommendations, and ASG target lifecycle state changes. The strength of this mode is simplicity. No extra AWS infrastructure needed. No SQSQ, no event bridge rules. Just deploy the daemon set, and it starts watching. However, there are limitations. IMDS mode does not support lifecycle heartbeats, those extended drain windows that give slow workloads extra time to shut down. It cannot handle ASG lifecycle hook orchestration, and it depends on IMDS being reachable. If you disable IMDS entirely for security hardening, this mode cannot function. The recommended approach is to use IMDS version 2 with a controlled hop count, not to disable IMDS completely. Think of IMDS mode as a reliable local fire alarm. Fast, simple, but it cannot call reinforcements. Queue processor mode is the more powerful option. Instead of watching local metadata, a central NTH deployment pulls an SQSQ. That queue receives events from two sources: Amazon EventBridge rules that capture EC2 interruption and state change events, and auto-scaling group lifecycle hooks that pause instance termination. When NTH reads a message from the queue, it identifies the affected EC2 instance, maps it to the corresponding Kubernetes node, cordons it, and drains it. The most powerful feature of queue mode is lifecycle heartbeats. When an ASG lifecycle hook puts an instance into a waiting state, NTH can send periodic heartbeats to extend that wait. This is invaluable when you have pods that need extra time. Log shippers flushing buffers, batch workers checkpointing progress, or stream processors committing offsets. Queue mode requires more AWS infrastructure. An SQSQ, event bridge rules, IAM permissions via IAM roles for service accounts, and optionally ASG lifecycle hooks. But it decouples event production from consumption, providing buffering, retry, and centralized observability. Let us trace a complete spot interruption using IMDS mode on a self-managed node group with 10 nodes, 4 of which are spot. At time 0, AWS decides to reclaim a spot instance. It publishes an interruption notice into the instance metadata. Within a few seconds, the local NTH pod detects the notice. NTH immediately calls the Kubernetes API to mark the node as unschedulable. That is the cordon step. Then NTH begins evicting pods. That is the drain step. As pods receive their termination signal, pre-stop hooks run, containers get a graceful shutdown window, and the Kubernetes scheduler starts placing replacement pods on healthy nodes. Service endpoints update, so traffic stops flowing to the dying pods. At approximately 120 seconds, EC2 terminates the instance. The critical lesson here is that the 2-minute window sounds generous, but in practice, detection takes time, endpoint updates take time, and drains serialize. High pod density or strict pod disruption budgets can eat most of that window. Now let us trace an ASG scale-in event using queue processor mode. Imagine a 20-node self-managed group with lifecycle hooks, SQS, and event bridge configured. At time 0, the auto-scaling group selects an instance for termination and puts it into a lifecycle wait state. Within 1 second, the termination event lands in the SQS queue. NTH picks up the message, identifies the EC2 instance, maps it to a Kubernetes node, and cordons it. Drain begins. But here is the power of queue mode. If the drain is still running at 60 seconds, NTH sends a lifecycle heartbeat to extend the wait. At 90 seconds, drain finishes. NTH completes the lifecycle action, and only then does the ASG actually terminate the instance. This is the most controlled, graceful termination pattern available for self-managed node groups. The lifecycle hook plus heartbeat combination gives your workloads a predictable, extended drain window that IMDS mode simply cannot provide. This is the most important decision in modern EKS architecture. Do you even need NTH? The answer depends entirely on how your nodes are managed. For self-managed node groups, yes, NTH is highly relevant. You own the auto-scaling group behavior. You own the disruption handling path, and you need a bridge from AWS events to Kubernetes drain behavior. For EKS managed node groups, usually no. EKS managed node groups already provide integrated graceful handling, including spot rebalance behavior and drain flows for managed node lifecycle events. AWS documentation explicitly states you do not need NTH here. For Karpenter managed capacity, definitely no. Karpenter has native interruption handling built in. Running both NTH and Karpenter on the same nodes creates conflicts. Both try to handle the same event. Here is the golden rule. Self-managed nodes, use NTH. Managed node groups, skip NTH. Karpenter, use Karpenter's own interruption handling. That one decision prevents the most common production design mistake. Draining is where real-world incidents happen. Let us understand the mechanics. Cordon means marking a node as unschedulable. No new pods land there. Drain means evicting existing non-daemon set pods. You usually want both. During drain, each pod receives a SIGTERM signal. If a pre-stop hook is defined, it runs first. The pod then has its termination grace period to shut down cleanly. Pod disruption budgets, or PDBs, limit voluntary disruptions. If a PDB says at least 2 replicas must always be available, the drain cannot evict pods below that threshold. This is where a common anti-pattern appears: a strict PDB, a long pre-stop hook, a generous termination grace period, a small cluster, and a spot interruption. The application simply cannot evacuate in time. Daemon set pods are not evicted during a normal drain, and stateful workloads are especially sensitive because they may need storage detach and reattach cycles, quorum transitions, and leader elections. Plan for these explicitly. If NTH fails silently, you only discover it when nodes die abruptly. Here is what to monitor. NTH logs are your primary truth. They show event detection and drain actions. Kubernetes events reveal evictions, cordon activity, and scheduling decisions. In queue mode, watch SQS queue depth for backlog and event bridge delivery metrics to verify events are reaching the queue. The most common failure modes are predictable. NTH never reacts. Check wrong mode, wrong permissions, or IMDS blocked. Queue mode receives nothing. Check event bridge rules and SQS policies. Drain stalls. Check pod disruption budgets that are too strict or API server throttling. Heartbeats are ineffective. Check that the ASG lifecycle hook timeout is long enough. A practical troubleshooting checklist starts with confirming whether you actually need NTH for your node type. Let us talk production-grade design. For self-managed on-demand nodes, Q mode gives you full lifecycle hook orchestration. IMDS mode may be enough if you only need basic interruption detection. For self-managed spot nodes, NTH is a strong fit. Q mode with lifecycle hooks gives the most controlled drain window. For EKS managed node groups, use the native managed behavior. Do not add NTH unless you have a very specific, validated need. For Karpenter, use Karpenter interruption handling. Beyond the node type decision, follow these SRE design principles. Separate spot and on-demand into distinct node groups by workload tolerance. Keep termination grace periods realistic, not longer than your actual drain window. Avoid overly strict PDBs on spot-heavy groups. Use topology spread and anti-affinity to distribute risk. Run game days that simulate spot interruptions and ASG scale-in events. And never co-install overlapping interruption handlers on the same nodes. Here is the mental model you should carry. AWS Node Termination Handler is a translator. AWS says this EC2 node is going away. NTH tells Kubernetes to stop putting work there and move current work away safely. IMDS mode is the simple local watcher. Q mode is the powerful centralized controller. The critical decision is about node ownership. Self-managed nodes, use NTH. Managed node groups, skip NTH. Karpenter, use Karpenter's own handling. Design node interruption handling as a platform capability, not a one-off add-in. Test it with game days. Monitor it with real metrics. And never assume Graceful means zero disruption. That is the complete AWS Node Termination Handler story. From the gap between AWS infrastructure events and Kubernetes node lifecycle to a production-grade disruption handling strategy. If this masterclass helped you design safer EKS clusters, subscribe and share it with your team. Thanks for watching.